In this video, I will be showing you how to find domain and range for various graphs. And these are problems that can be found in chapter 1. And I will be showing domain and range using interval notation. So let's take a look at the first example. We have a graph that is, the graph of a function that is continuous. It's one continuous segment. So let's take a look at that curve and let's ask the question, what is the point that is furthest to the left? And that's going to correspond to the smallest x value. So that point corresponds to -2, -1. That's the point furthest on the left side on that little curve. And but since we are going to find the domain, we only take a look at the x value for that point right there. And so the x value for that point is -2. Now I ask, what is the largest x? And that point, or that x value, is going to be the x value that corresponds to the point on that curve that is furthest to the right. And so that's the point, and that corresponds to an x value of +3. So we say that the domain spans from x equal -2 all the way to x equals 3, the smallest x, all the way to the largest x value. All right, so that's the domain. Now let's do the same thing for the range. Now for the range, it's more looking at the y-axis, the y values. So the smallest value, the smallest y value on that curve, once again, is the same, happens to be the same point that is furthest to the left, but it's not a question about it being furthest to the left. It's just it's the question of that point is also the lowest point. It has the lowest y value, and that y value corresponds to y is equal to -1, as you can see right there. Y is equal to -1, and the highest y value is y is equal to 2. And I'm going to make a line all the way to the y-axis, and you can see that that point there has a y value of 2. So the range then spans from y value of -1 all the way to 2. And that is the range. Now let's take a look at problem number 2 now. For the domain, once again, we only take a look at, we are only concerned about the x values that are used for making that function. And so we ask again, what is the smallest x value? And the x value happens at the point that is furthest left on that curve, which is right here. And that x value is -3. And then the largest x value corresponds to the point that is furthest to the right on that curve, and it corresponds to x equals +2. So the domain then ranges, or spans from -3 all the way to 2, and we put -3, 2 in brackets, and that's how we represent the domain. Now for the range, let's take a look at the lowest y value, and start there, and then go all the way to the biggest y value that we have here on this graph. So the lowest point that I see on this curve is that y is equal to 0. There's nothing below the x-axis, so y is equal to 0 is the lowest point. And the highest point looks like it's right there, and that corresponds to some number that is between y is equal to 1 and y is equal to 2, let me just say that let me just say that it's y is equal to 1.5. So the y's then span from 0 to 1.5, and that is the range. In the next example, problem number 3, we have 2 segments, and these 2 segments are not connected. So we're gonna, when we write the domain, we're gonna write 2 separate domains, or 2 separate intervals to express the domain. Let's start with this segment over here on the left side. The smallest x value is the point that is furthest to the left, which is right there, and that has an x value that corresponds to -2. And the point to the right, or the point furthest to the right on that segment, corresponds to x equals -1. So we have -2 all the way to -1. So when we write the domain, we put -2, -1, from -2 to -1. That's the x. Now let's get the domain of the segment on the right. So there, the point furthest to the left corresponds to x equal 1, and the point furthest to the right of that segment corresponds to x equals 3. So we need to make another interval for that. And so that is it. That is the domain. Now for the range, now let's take a look at the y-axis, at the y values. Once again, let's start with the smallest y, and we're going to find the smallest y in this segment over here that happens to be on the quadrant number 3 on the left side of the y-axis. And this point, the furthest point that is, or the lowest point, corresponds to y is equal to -3, and the high point on that piece of segment, corresponds to y is equal to -2. So we write that interval from -3, all the way to -2. Now we do have this other segment over here in quadrant 1, and the smallest y value there is the point furthest to the right, and that corresponds to y is equal to 0. So we write in brackets 0, the highest y value corresponds to the point over here, and that is y is equal to 1. So here are the 2 intervals for the range, and that's done. Now let's take a look at problem number 4. Once again, here we have 2 segments, or two pieces of curve. So I'm going to have express the domain as 2 separate intervals. We start with the smallest, with the segment on the left side of the y-axis, because it also has the smallest x value. That x right there on the left side corresponds to x value of -2, and the point that is furthest to the right on that segment there corresponds to x equals 0. So we have, once again in brackets, -2, 0. Now moving on to the other segment, the smallest x corresponds to, the smallest x on that segment is the value x equals +1. X equals +1, and the point furthest to the right is x equals +3. So we need to make a bracket for that. Okay, so that's the domain. Now for the range, we look at the y values, and if we take a look at the segment on the 1, 2, 3, 4 on the 4th quadrant below the x-axis, all that segment, that's a horizontal segment there. All of that has a y value of -1. And so it's not an interval, it's just that one number, y is equal to -1. So that takes care of that segment. Now this other segment in the second quadrant, the smallest y is right here, and that corresponds to y is equal to -2. And the highest y value in that segment is up here, which corresponds to y is equal to +3. So we in brackets we write from 2, 3. Okay, moving on to example number 5. Here we have a single curve, and the domain once again corresponds to that point that is furthest to the left. The smallest x value goes so from -3 all the way to x equals -1. That's where that curve spans the x's. The x values span from -3 all the way to -1. The y values, to get the range, the smallest y is down here. Corresponds to y is equal to -2. And that goes to y is equal to +1. That's the biggest y value. So that is that for number 5. Now for number 6, we have a combination of 3 items. We have two of them which are dots, and then we have this little curve on the right side of the y-axis. So let's start with the domain. The smallest x is going to, once again, you're going to find that on the point or curve that is furthest to the left. Well, that corresponds to that point there, and the x value for that is x equal -2. Now the next smallest x is a little bit higher, and that corresponds to x equals -1. So we write x equal to -1. Now we still have this other segment on the right side of the y-axis, and the smallest x value for that little segment starts at x equal 1, and it goes to x equals 2. So it goes from 1 all the way to 2. So we put that in brackets, and that is it. That's how you find the domain of these points along with that curve. Let me just finish up by doing the range. The range. Now we're looking at the y values. The smallest y that we have anywhere here is going to be found in this segment right here on the right side of the y-axis, and that y value is -2, and it goes from -2 to -1. So we write that as an interval, -2, -1 in brackets. Now the next smallest y happens to be this point here. Let me make it a little bit bigger. That point there, and that has a y value of +1. So we write y is equal to 1. And finally, we have another point that has a y value of 3. So we write y is equal to 3. And that is it.